Welcome to another live star stream of Planetarium. My name is Levent Gürdemir, astronomer at UTA, and we are here with you with another live stream. So if you have questions, please use chat to ask your astronomy, astrophysics related questions. I think Jim has some news for us today to talk about, but in the meantime, if you have any questions, we'll go ahead and answer those too. So, Jim, what's going on in the space today?
We got a whole bunch of stuff, a whole lot of stuff going on. So, to start with, magnets in space. I thought this would be a good place to start.
Just magnets all around the world, right?
Yeah.
On the refrigerators.
But the real problem, I think, that we have this magnets in space situation going on, or why they would want to put it there, is because of all this stuff that's in space, right? There's like a bunch of stuff in space. So this company, Astroscale, devised an idea to make a spacecraft with a magnet, and it will go up and attach to spacecraft and try to pull old debris into the atmosphere. And this kind of clever. This supposedly was supposed to launch last weekend with a Soyuz rocket from Russia. It seemed really neat. I was just curious what your opinion, how you felt about the idea of something to get rid of all this space debris, because there's so much of it.
Yeah, but let's talk about where the junk or the debris comes from and how a magnet can help. Well, it's a good idea. I hope it works. But this is pretty much showing the officially known satellites around the Earth real time. So we are good about just putting more and more orbiting small boxes in space that we call satellites, and they serve for many, many different purposes, from monitoring weather to maybe a military purpose, of course. Communication is a big thing, and science experiments as well. So there are that many man-made satellites orbiting our planets, but each satellite have a lifetime. And that lifetime is, for some satellites, very short, especially if satellites have to keep a low orbit, like TV satellites, for example, broadcast satellites. They are low enough that they encounter the air friction all the time. So that shortens the life of a satellite.
Mm-hmm.
So if the satellite lives between 20 to 50 years, and after that point, what would you do with the satellite after it is at the end of its lifetime?
You'd hope that it would just burn up in the atmosphere, right?
Well, some do and some don't. The burning in the atmosphere is also a different thing, because in most of the time, because the satellite is out of pretty much most of the time out of power. So how are you going to control the satellite? So there is no good way of getting a controlled free fall. Well, if
do you think they could just, have the orbit decay at a rate that when, hey, its expected lifespan is 25 years. So the orbit of this spacecraft will decay after 30 years or whatever. So to give them 5 extra years in terms of lifespan. I feel like it just seems like, I don't know.
I mean, it is hard to estimate, and also even at the time of the decay, there's a lot of uncertainties, like the weather and wind and everything. So we don't know where the satellite is going to land. Well, if you think about 75% of our planet is covered by water. So that means 3 out of 4 chance that anything that falls from sky will end up in water. And most of the time, this is not a concern, because it dives into the water and disappears. But what if it hits the land? If we think about big percentage of the land is not civilized area. So it can be maybe nowhere in the mountain range, in the woods, in the ice block, or in the middle of a desert. So we don't care, right? I mean, if we find it, that's good. But what if it falls into a civilized area? Even though the chance is small, still there's a chance. So that's why we do not like uncontrolled satellite falling or uncontrolled um, space debris falling from space.
Especially for things like if you're going to launch a rocket or have the ISS flying around, if there's uncontrolled stuff up there.
But if we think about it, we
rip a hole in the ISS.
Keep putting up things in space that orbit started from 1950s. There is a bunch of them, and there are also a lot of satellites that were lost and currently uncontrolled. So this stuff can be dangerous, and there are some of the things that known where they are, and some of the things that they are not known where they are. So we keep putting that things, and after we lost the control, we lost the signal, or they are at the end of their life, it is not cheap to recover the satellites if they are dead. So that's another expense to just go grab them and bring it down back to Earth and recycle, and it's not easy. So for that reason, at one point, that becomes a major issue. And I think this type of design is like, hey, put a spacecraft in the orbit. It has a magnet, and magnet orbits collects the debris. Well, this spacecraft, apparently it's not designed for grabbing an entire satellite, because it's not gonna be efficient, or it's not gonna be a lot of sense to for that thing to grab a satellite. So what you're gonna do after grabbing a satellite? Because then that's gonna be just adding another big mass. It will change the orbital dynamics, so you will have to worry about the fortune of this combined objects together, and that's going to be a lot of problem. But it seems like this debris collector is designed to collect small debris, which satellites sometimes, like even like burning in the air, leave a lot of different particles or small particles after them, and I think this is going to collect them.
Yeah, it's certainly cool to imagine there's a big magnet to clean up all that junk that's up there. And we got, hey Brexton, how's it going?
Hi Brexton, good to see you here.
Some questions from Brexton in the chat.
I was looking outside and saw a faint red light went from east to west. Was this a satellite? Well, the satellites do not appear as like there's a lot of differences from meteors or different things. Satellites usually appear as a constant light moving at constant speed in the sky, and yeah, most of the times they are faint. I cannot comment on the red color because that depends on a lot of things. Usually, the satellites appear like small lights. It may look like an airplane moving, and then at the constant speed they are moving. It's not at the first sight. It's not possible to distinguish from a high-flying airplane than a satellite. But if you go to there's a very good website for that. It's called heavens-above.com.
We got a link for it in the chat.
Yeah, but that website lists, you put your location in, and that website lists all the visible satellite passes in your area. And it's very useful if you need to identify a website.
Really good asset.
Especially if you catch International Space Station, ISS, or some of the bright satellites like the Starlink satellites.
We had ISS recently, just I think it was a few days ago.
Yeah, Iridium flares, the Iridium satellites, I don't know if they are still around, but they hit huge solar panels, reflective panels, and when they turn, they tend to brighten up significantly in a few seconds, and then dim back down, which created a flash effect. So that event's called later Iridium flares.
Those are crazy. Yeah.
So if you catch an iridium flare, that's a very good way to impress people, because if you say something like, hey, look in this area, in a few seconds, a bright light will just flash and disappear, nobody's going to believe you, but after that happens, you can just
All right. So Mary asks, how will this magnet differentiate between live satellites and dead weight? I didn't read too much into this, but my assumption was that it was just going to pull satellites down that it knew were dead. So we do track the location of things, right, Levent?
yeah, I think this satellite is a conceptual design, right? This is
No,
not something
it did
that
launch.
It did? Okay, so yeah, we need to
But
read.
it's not for everything. It's just going to be for, it's going to grab some objects. This is a Japanese company managed through the UK or something like that, Astroscale.
Yeah, maybe wherever they are orbiting, there are no more live satellites, because it's usually the satellites, you just leave them in an orbit, and then they orbit them until the orbit decays. Moving the satellites to change the orbit, like some movies feature, they have like propulsion jets. The satellites trigger them and then change its position. That's highly expensive thing, and most satellites don't have such things.
So this is gonna go after. It's not just a big magnet and doesn't just stick to the nearest thing. It will go after and retrieve specific objects. So.
And also, after it gets more and more matter onto it, so the weight, the mass of the satellite will increase, and that increase will result in satellite changing its orbit closer to Earth. So maybe, I don't know, I didn't read the design things, but maybe it is designed as to start from some point and gain weight and get closer to Earth, and in the meantime just make like a sweeping effect towards the Earth. But of course, at the end, it needs to be calculated and considered that where it is going to land at the end of the journey. That's very important.
I agree there. Brexton says, can they salvage old satellites in space? Not that I know of.
Well, yeah, so far no requirement was made for satellites to, the salvage, but it's very common that the satellites sometimes fall from sky. Well, at the end of the satellite's the lifetime, two things is going to happen. Either a satellite will move away from Earth and disappear in the space, or it will just come back and fall down Earth, and this is actually what happens most of the time. Why satellites cannot survive in the orbit forever? Well, in theory, you put a satellite in an orbit and it's there for forever. But in reality, it doesn't happen, because there is a lot of other gravitational influencers in the solar system. Moon, for example, some other planets tug force, even the sun does the same effect. So with the all gravitational and the changing influencers, none of the orbits actually remain stable around Earth and in the solar system. For that reason, there's always slight changes in the orbits, and these changes either move satellites further away from Earth or closer to Earth. So every orbit will be affected, changed, and decay after some time.
All right, last question on this before we have to move on to the next one. But Kurt had a really good question, so we'll drop this one for everyone to see. The spinning molten core of our planet generates electromagnetic field that reaches out beyond the surface and protects us from all kinds of radiation and debris. How can such a weak field make such a huge difference?
Because of the electrical power. So the electrical power, there's electric field. Those belts are actually the belts of electric fields. So what happens is the electrically charged particles are moving in space from the stars, from the sun, towards Earth. And there is the magnetic field, which is also an electrical field. When they get together, regardless how strong or how weak the force is, the electrical field traps the particles and just change and guide them into different direction, in the direction of electrical field or magnetic field. So this results, the particles when they are flying towards Earth head on, being diverted to along the magnetic fields, which terminates at the magnetic poles of Earth. So that means if we are in Texas in low latitude places, we don't get to see those interaction of these electrical charged particles. But if we are living near poles, close to the North Pole or close to the South Pole, for example, what happens is because the magnetic field lines poles, which are terminated on the planet, they are getting interaction with the air because they get pretty low, and the particles go to the atmosphere, and there is the interaction starts between the air molecules and the charged particles, and those show up as northern lights or southern lights.
I hope to see those someday.
Aurora.
All right, let's move on to next important news story. This is really neat. I was so excited to bring this one up. So this is this is the InSight Mars lander.
Finally,
you can see here. And InSight's main duty was to just check for vibrations. So Marsquakes, learn about the internal workings of Mars, and we got, this is exciting, just a few days ago, we got two pretty big quakes. It's really easy to call them earthquakes, but
Marsquakes.
Yeah. So it's found 4 really big quakes so far, and by really big I mean they're 3.1. It's like 3.1, 3.3. Biggest one was 3.5, I think.
Mm-hmm.
And they keep happening in the same place on Mars. Fortunately, we have the ability to just show you guys where it's happening. This place called Cerebus, I can't pronounce it, but we put it on the screen for you to see.
But the quakes were a result of volcanic activity, right?
Yes, yeah.
Because the quakes can happen in 2 ways. They are either like from the internal reasons, the volcanic activities, or impact of a big object like a big asteroid or a comet also creates the quakes. Well, if we think about Mars, yeah, Mars is prone to the asteroid impacts and comet impacts because it have thin atmosphere. But what we think is the inside of the Mars is cool, and it should not produce a lot of quakes. But this data and this type of data reveals that our knowledge about the interior Mars is not complete, and these quakes are providing essential information about the interior workings of Mars. Why we see volcanic activity in the inside of Mars.
Super interesting to me. But anyway, next article. This one really. There are some articles that maybe I find a little bit later. Some I avoid. Some I feel like we need to save for a different time. We have one that I really thought about using today, but maybe you'll see it next week or the week after. We'll have to see. Very good one. But this is one that really just stuck in my eye, pun intended. And this is about the expansion of a totally different concept of a telescope. This is crazy, Levent. So I think you read a little bit about this. Somebody took, instead of using one single lens or one single mirror, they took a whole bunch of Canon lenses and cameras and combined them to take really high-resolution images. Right now, I think there's 42 cameras total, 2 different sets of these 24. But they wanted to expand it to add another 120 cameras to it.
The telescope technology is certainly improving, and traditionally we just used bigger and bigger telescopes to see dimmer and dimmer objects, and telescopes had precise mirrors and lenses and used the combination of those. But today there are some modern telescopes coming up in the markets which are amazing, and I heard the company, which I'm not going to tell its name, but apparently they included a lot of electronics in the telescopes that they capture the images and in real time process the images and send it back to the viewer digitally. Well, those are not optical telescopes anymore because they are like like the camera, digital cameras. They take the pictures, they image process it on the fly, real time, and then they give the results to the viewers immediately, which is amazing technology that makes possible to see the distant galaxies and nebulae pictures with the small telescopes.
Yeah, this also, to me, it seems like it's going to be a lot easier to repair if something is
Mhm.
wrong. You just swap
Yeah.
the lens out. I have a bad sensor in one of the cameras. I swap the camera, the sensor out. It just seems like really easy to upgrade. Also, fun fact: this was started. The Dragonfly telescope, what we're looking at here, was started in part by a professor from the UT system. So
Yeah.
UT Austin, pretty neat.
And imagine, probably this telescope is performing the same way as if a single lens was about that big, and manufacturing that big of a lens is significantly higher than the cost of individual lenses like these.
All right. So, last news update. These are always my favorite to get to. So let's go ahead and bring to you guys. I wish we had a siren or some alarm to go off. We have news from Mars. Anyway, let's get into what we want to talk about for sure. So, we have some updates on our Ingenuity, which we're very excited to bring to you. And just a recap of what we saw.
Oil change.
Yeah, oil change. Over the last few weeks, I have to get rid of my face to show you guys this, but we saw the. It just looks like, you just dropped the pan on an oil. Anyway, they dropped the lid to free Ingenuity. They moved forward a little bit, set Ingenuity down so we can see that image, which I hope I have for you guys. Somewhere. Yeah, here we go. Wonderful. Took me long enough, but there we go. Okay, so they
Here
set
you
it
go.
down.
Finally on the ground. I'm seeing it this picture for the first time.
Yeah, this is awesome. So it is free. It's all by its poor lonesome. All alone out there. Poor little Ingenuity. It spent its first night by itself, and NASA was a little nervous it wasn't going to survive the cold because the temperatures dropped down to negative 130. So it's pretty brutal.
That's cold.
Yeah, not a temperature I think that I would enjoy experiencing, to say the least. And we also got, which I guess is a little bit out of order, but we also got a picture from the surface. So this is its super low resolution image from Ingenuity's own cameras. It's when it flies, it's going to be able to take pretty good videos. I think hopefully we get a little higher res images from that. It's also possible that the only image I could find from NASA was this low res one. There's higher res somewhere else that I was unable to locate. But still pretty interesting. And we're excited. I'm excited certainly to see what we get in the future.
Isn't that amazing to just think about two things on the surface of Mars, on a different planet? On their own, they are taking pictures, they are moving around, and they are sending the information back to Earth.
It really is. It's crazy.
So, and we have the ability of sending those and making them operating pretty much on their own. One drops the other and then moves away from that, and this will start up and start flying, and the
On its
rover will
own,
be
too.
taking pictures and video of its first flight. Amazing. I mean, amazing engineering.
It really is. It just blows my mind that it's gonna. I mean, it knows where it's gonna go. It's gonna fly around, and you're gonna have another spacecraft like keeping or another craft on the surface, keeping an eye on it. So that's just crazy to me. I mean, the rover's gonna land in a certain place, is gonna fly, and while this whole thing is happening, Perseverance is just gonna watch while the little drone flies around. It just blows my mind.
And
sure.
if the drone is successful to fly, I think the further missions, future missions, will be drone missions
Yeah,
to
then
the
that's
surface, which can achieve longer distances in a shorter amount of time.
definitely that's something that kind of is crazy to me, is that we watched Sojourner was the first rover, which we talked about in previous episode. Levent mentioned, and it was a test. It was just like, hey, we put wheels on this thing and we let it drive around a little bit, and we might do this in the future. And it was successful. So now it seems silly if we were to send something to Mars and not put wheels on it. Like when I see the InSight lander, I just feel like, why doesn't it have wheels? That's the only one that makes sense to not have wheels, because its whole point is to feel the ground. I almost call it the Earth. But yeah, so now will the future just mean only drones?
Yeah.
Well, we'll find out. Anyways, it was supposed to take flight tomorrow. Originally was the date that I saw was going to be April 8th. So I was kind of hoping that today we would get to talk about like, oh, this is about to happen. However, they moved the date. They're expecting it to go on April 11th. And until April 11th, they're going to be testing other things. I think tomorrow they're actually taking off the clip that holds the rotors down. They can't move right now, so they're removing that clip. And they're going to start the engine up and test, and we'll have some news for sure next week. No doubt about that. We got a question from Lamia. Are such machines able to self-check and maintain if necessary?
To some extent, yes, because the way it works at that distance is because there is a significant signal delay, if you think, between Mars and Earth. We cannot just, it's not practical to send real-time commands. So these machines, since early 2000s, designed to have their own intellectual capabilities. So that's where the machine learning goes into place, because they are able to, like, for example, get them out of trouble if they like get stuck on a mud or in a sand trap or any like obstacle. They are able to assess the situation. Hey, I'm not able to move anymore because I have a problem. And then the machine has the ability of think that how can I get out of this situation, and let me try this and let me try that, and they have the ability of the decision making. Of course, to some extent, they are not super intelligent machines, but the software is at the enough level right now that they can do simple tasks on a need basis.
Yeah, what blows my mind is the drone capability for it to dodge things. And you can see these on Earth. There are videos of people who have given drones enough AI that you can watch them trying to hit them with footballs and frisbees and rocks, and the drone will just pop in and out of the way and dodge it and continue on its course that you've mapped it. So I can only imagine that if that's happening on Earth, then this helicopter they sent to Mars has similar software.
Yeah. And they keep getting better and better.
Crazy. Crazy.
Yeah, I cannot wait for the future that is going to follow up with Ingenuity in the future to for the Perseverance rover to get the collected samples and return them to Earth. So we have not have returned or any like Mars rock samples on Earth other than the fallen meteors. But in the future, hopefully the Perseverance will collect some interesting rock pieces, and a future mission will just collect them and bring back down to Earth. So we will have real Mars samples.
Yep. Well, that's all the news I had today, Levent.
Janet says, I thought Integrity had a new name. Ginny is the...
Ingenuity, yeah, Ginny. I have it in my notes. Ginny, I think it's important that we use Ingenuity as much as we can. I do love that it's Ginny. It's kind of nice that it's the first Mars craft that has, in my opinion, a little less masculine of a name, or a little less boring of a name when they call it Ginny. Percy and Ginny. I love those names. Are awesome. I love the nicknames for them.
There are some questions coming if you would like to read them.
Huge question from Kurt. We can drop this for people to see.
What is the most inhibiting thing about Mars? Greatly, out of the way. Greatly reduced gravity, which prevents us from staying long term. In other words, what will be the hardest aspect of its gravity for humans to overcome? I don't think the gravity is the most difficult part over here. The problem is, the biggest problem is going there. The travel, and the second problem is staying there for the long term is the lack of oxygen. Well, the travel is hard because it takes about 9 months each way, and for the 9 months you have to carry the spacecraft it needs to carry a lot of oxygen, food supplies, pretty much a lot of things and also in the 9 months of travel, like even the astronauts when they stay in the International Space Station a few months, they are experiencing a significant muscle problems because muscles weaken up in the non-existence of gravity.
A lot of stuff, a lot of health issues.
Yeah, and one of the thing is just keeping the heart in a good shape. Heart is also working with a lot of muscles to pump the blood, and if the muscles weakening, so the entire the organism, the entire body have a lot of issues. So this is one of the problem the humans needs to overcome. The second, when they get there, the Mars air is not a breathable air, so they will need a lot of oxygen supplies, etc., and food. And the coming back, they have another threat. When coming back, they need a launch, the spacecraft launch facility, which hasn't built yet.
Do they get to come back, Levent?
Well, it depends up to them. I mean, if it was me, yes, I would love to come back if I go to Mars one day. But if they choose to stay there, they are more than welcome. But then they need to figure out a way to harvest the oxygen and food and everything.
That just seems so brutal and like it's just dark. Imagining, I'm not coming back to Earth. I'm leaving the only place that humans have ever lived successfully forever. That seems like I just can't imagine anybody signing up to do that. And I know that there have been calls for people being like, hey, I would like to send people to stay there and not come back. Would you do it? People signed up. And no, a hard pass. Hard pass. Can you imagine that? They get launched and you're just like, see ya, hope it works out.
I don't know. I mean, there's a lot of things to do on Earth, which is fun, and I don't see any. Have you seen any fun places around here? I mean, maybe hiking, but after some time you will get bored hiking. So what you gonna do then? Your favorite restaurant is not there. Your friends are not there, and there's no internet. There's no Wi-Fi coverage on this planet. Well, let me tell you.
That's the deal breaker for me.
That's the deal breaker, right? Especially for the new generation.
Latency too. Gosh, the latency would be so bad. I couldn't handle that. I mean, you hit pause or something.
If you tell my son there is no Wi-Fi, he won't go there. His criteria is pretty. I
agree on it. All right, that's everything. Do you have anything else?
No, let's move on to the next thing.
That's it. That's all my news. I'm out.
What is after Mars?
That's all my news, Levin.
That's all your news?
Yeah, that's all the news
I
got.
Is that all?
I mean, we have other things, but time-wise, I decided today to just keep it. We've got some really good third grader jokes for maybe next week, but yeah.
All right.
Anyway.
Well, okay, then see you next week. Let us know if you have any questions so we can get that question answered in the next time.
Yep. Thank you guys so much. See you.
Bye-bye.